I'm recording it.
Okay, I'm recording it. Never mind.
Oh, yeah.
All right. See, so I don't know if, I guess this probably starts the recording from right now. Whatever. Okay, so look, you get mg 1015. Okay, so this will tell us the electric force. We know the mass is 2 grams, so it's 0.002 times 9.8 times the tan of 15. And we'll get a tiny number, I imagine, right? So it'll be 0.002 times 9.8 times 15. Okay, that's equal to 0.00525. Okay. All right, I'm going to just store that in memory. And then once you've got the force, then you can just go like this, that the electric force, we'll use the formula.
How about the other side? Is it the same thing? Yeah, because it's the same.
The other side would get the exact same number.
Oh,
We
yeah.
just in the opposite direction. It's action reaction, right? But the math would not work out any differently if we did the other side. We only have to do one side. Okay. So we know that Q1 and Q2 are equal because it says they're identical charges. So we'll just call it Q. So this will be KQ squared over R squared, like that. And we just put in our number, right? So we go 0.00525 for the force. Now we have to get R. R is, there's a little bit of math here. R would be this distance between the two charges, right? So this is where the 0.3 comes in, okay?
So it's, how is it?
What I would do is I would just draw, my pen works here. I would just draw there, okay. I would just draw a line down here and bisect that angle. So we know we got 15 degrees there. And we'll call this X. X would be half of R, right? And this is a little right angle triangle.
So what's, so the green line, what's its measurement?
Well, you don't need it. What I would do is I would go like this. I would use SOHCAHTOA. So I would say the sine of 15 equals X over 0.3, right?
Oh, yeah.
Does that make sense? And then go X equals 0.3 times the sine of 15. And R will equal 2X, okay? Okay, which is equal to 0.6 times the sine of 15. So you can just, put that into your calculator, and there you have it. 0.6 times 15 sine. It's nap time, that's why.
I just woke up.
1:05.
I woke up I woke up 12:26, but I went back and I woke up at 1.
See, I really don't feel like it's racist for me to say that, like, it's a kind of a Middle Eastern thing, napping in the afternoon.
I don't like the beginning of that sentence.
Like napping afternoon?
An afternoon nap. If Dominique is here she's at work right now, but if she's here in the afternoon, she's on the couch asleep. Like
She's tired.
That's just every day. And like when I was younger, like Mr. Diab and I did a road trip to Florida and stuff. Same thing. If we were in a place where you could take a nap in the middle of the afternoon, he's napping. That's it. Like,
oh my God! Always has something to talk about. Let us nap. Like, it's not a Middle Eastern thing.
No, you know what? I admire people who can nap just like that in the middle of the day.
Because, like, how do you expect us? Like, personally, me, when I come back from school, I have to nap. If I didn't nap, I'm not going to be able to work, like homework and my other stuff. I have to nap.
You know, I get it, because I get tired in the afternoon, but I can't nap. Like, my body just doesn't let me nap.
Once I lay my head on the pillow, it's just boom. Like, I just turn off.
Okay, when I just worked out the answer. Here, you know what? I'm going to get rid of this.
So you're finding Q, right?
Yeah, and I got 1.19 times 10 to the negative 7 coulombs.
Yeah.
Okay, so so I mean, you just got to, I think the key is doing the free body diagram. Like
And
you
knowing like 15 and
yeah, yeah, there's a few little irritating things. The funny thing is, if we had done the lab in class, you would know it because it's exactly what we do in class. Because the reason why they give you the 0.3 and 0.3 is because when you do the lab, you before you charge the balloons, you lay it out on a table and you just measure the total length before you pin it up, because it's way easier to measure it there. And so that's why they give you the numbers that way. It's not just to trick you or something. It's just that's how we do the lab. So.
Excuse me, sir. I have a question. Like, what's the Unit 3 homework mark for?
I don't know for the
What
unit
part
3.
was it?
Like, I got to go back and check it. Like I said, I would. I don't know why I didn't give people 100%. But
'Cause,
like here, let's see. So unit 3 would have been like the energy momentum, right?
Oh, hers is way more.
Momentum energy.
I just spent all of my.
No, that's what I did at first, and then I couldn't remember which ones I posted, so I just like redid
How
it.
do you have the patience?
You know what though? It's way better for me if you post them
Yeah,
separately like
I
that.
know.
So if we go to Whitley's, let's see.
No,
Look at this.
It's just
Yeah. One page, and I got to figure out like if everything's here. You know, like, see, my internet is slow right now. But yeah, this is a pain having to scroll through this whole thing. Whitley?
sorry. I'm sorry. But like, is the pandemic homework and the homework 3 homework is separate, right?
It should be under the same.
I mean, we're in the pandemic. I mean, like what I did was I just looked to see if everything was there. So the unit 3, if I gave more than one homework mark, then I would have given, like, every time I sit down to do it, I give a new mark from the new material, right? So.
Oh.
And I don't do that. I only do it like at the end. Like I don't want to do it during the unit. So.
And are we continuing taking?
Yeah. So what more questions then?
Yeah. So for page 335.
335.
Yeah. So
Okay.
number 6 and number 10.
331 to
335 now.
Number 6.
Yeah, it's the same concept, kind of.
Yeah, I think that you'll see now that you've seen a couple, like it gets easier. So.
Mm-hmm. See, I'm asking smart questions. That means I do my homework. That means I shouldn't be getting 8 out of 10, 10 out of 10 always.
Well, if you don't post it.
My questions show you that I'm doing my homework.
Yeah, well, you could just pull them off the top of your head. Here, how about this one? How to do this one?
No, it's clear that I'm doing my homework and it appeared to be a hard question. So I guess. How would I know? How would I know the page of the homework and the numbers that are included in the homework?
How would you know? Just by looking at the outline, maybe?
No.
What question is it?
This is page. What did you say it was, Helen? Page
335.
335, number 6.
Number 6, and then 10.
Page.
You don't even have to do number 6 on this page.
Yes.
Yeah, I don't think this was. No, this wasn't on the thing. It's just 5, 7, 9, and 10.
Oh, 5, 7, 9. Yeah.
Oh, yeah, I didn't assign this?
No.
No, it's 5, 7.
That's unfortunate because I put it on a test before. So that's
See what? Then do it.
Well, we'll do it just to show you that it's the same thing. Okay. So it says a neutral metal sphere A of mass 10 kilograms hangs from an insulating wire, blah, blah, blah. So this is a 2-meter wire. And an identical charge B is brought into contact with sphere A. The spheres repel and settle as shown in the picture. What is the initial charge on B? Oh, okay. So an identical metal sphere with charge -Q is brought in. This one, it's a bit tricky, but like I'll show you the steps. Okay. And they touches sphere A. And as soon as you touch two things together, they always have alike charges then, and they always repel after, right? Okay, but they will share the charge is what happens. Okay. All right. The spheres repel. Calculate the initial charge on B. So in other words, like they want you to find Q. Does that make sense? Like they want you to tell them what Q is. So A was neutral at first, okay, but then it shared the charge Q. Okay, does that make sense? So here's
Why is it negative Q?
well, they're telling you it's a negative charge. That's all. But you don't put negative signs in the formula anyway. So your answer will be a negative number because they're telling you it's negative. So we'll just do it the way we did the last one. And here, let's just draw a free body diagram of this guy right here. This is gravity.
So we'll draw the free body diagram as an object B or A?
On A.
On A.
Yeah, B must be, in order for B to sit there like that and not move, it must not be able to physically move somehow, right? Because like, if it were able to move, it would be like the last question with the balloons. It would be pushed to the other side, right? But I think B here is fixed, like it can't move. It's like a solid mass sitting on the floor or something. And A is hanging from a string, right? So it's A that we need to do. And this, now it's a little easier. This is 12 degrees. So they tell you that. So we don't have to divide it in half. There's two components to the tension force. So this is my force of tension.
We have the rope and we have...
Oh, sorry. Yeah, my force of tension is this vector here. Yeah, so we have the rope, we have gravity, we have the electric force, and again, acceleration is 0. Okay?
Yeah.
So then you just, again, same thing. You're going to go Fe equals Ft sine of 12, and then Mg will equal Ft cos of 12. Same as before, right? And then just divide them.
The direction of Fe.
What's
like,
that?
How do we know the direction of Fe? Because if
it has to repel, like it's repelling from. It has the same charge as B, so like charges repel, right? So it's being pushed away from that guy. Okay, because they have the same charge. All right. So anyway, you get tan of 12. So long story short, okay, you find the electric force. So if you want to know how to do this question, it's pretty much identical. But there is this thing, the charging by contact thing. Okay. So what we'll do is I'm going to call this like QA. Okay. So look, when you find the force, you're going to write that the electric force is equal to K QA squared. Okay. Divided by R squared. Now they think they tell you what, oh no, they don't tell you what R is. So R will equal 2 times the sine of 15.
Sine whatever, right?
2 times the sine of 12, yeah. Okay, so you can do all that. Okay, but anyway, when you find QA, so far it's identical to the balloon question. You're gonna get a number here, but that's not quite the answer, okay? And the reason why it's not the answer is because these two guys shared the original charge equally, right? So like, let's say you had, $500 and you share it equally with someone. That means how much does each person get? Right? Yeah, well, the answer would be half, right? Like each one would get half. So this, oops, I hope that didn't mess it up.
What's the mass?
The mass of it is 0.1 kilograms. It says in the question. But anyway, once you get this, you have to realize that QA is actually half of the original Q. Okay, that was given in the question.
Because it hit the other object.
Because it shared it, yeah, by contact. Okay.
But the other question, they shared it as well.
No, it didn't. You charged them separately. Okay, like it said they were given an identical charge by friction, but it didn't say they touched each other. Okay. So like, because they're asking us for the original charge, you have to multiply your answer by 2 because each sphere ended up with half the charge. So when you find the answer, this will be half of the original charge. Like this QA will be 1/2 of the original, right? Original charge.
Mhm. Oh yeah, because B was fixed and then A hit it.
Yes. So as soon as you get charging by contact, they always share half. Okay,
Mhm.
like they'll share the charge equally, whatever the total charge is. All right. So anything else?
10.
10, was that an assigned? Oh yes, I must have assigned 10, right?
Mm-hmm.
Okay.
My questions are smart, just like me.
This question?
10, 335.
We didn't do a quiz in this unit, did we?
No. Maybe next week. Yeah. Maybe next week on Thursday. Yeah. I just
Wow.
find it.
Because I mean, yeah, we'll just do nothing for a while, right?
Thursday sounds good, so everybody can like
Actually,
catch up.
we won't have a quiz. We'll just have a test. We're going to finish this unit this week. So.
Oh, ooh, so the test is gonna be crazy because we didn't have, like, we need to have a quiz so we can get used to the materials before.
Well, I
we
could
really-
give you a practice test so you can get used to the materials.
Yeah.
Plus, it's just based on these questions. Honestly, it's just based on these questions. That's it.
Yeah,
Okay.
but the trick is where you use your formulas. If you don't know how to use the formulas, you don't know.
Yeah, I mean that's the trick, right? But it's yeah, it takes a little practice. I don't think this unit is that hard once you get used to it. Like the questions we're doing now, it's about as hard as it gets. The ones on energy are actually really easy, but students get confused is what the problem is.
Yeah, I get confused.
All right, so 2 spheres are attached, like as shown in the picture, when a charge of whatever is placed on each sphere. The distance between the spheres doubles. Now, they're in equilibrium, so like right? Now it says determine the force constant K. Now this is one of those questions where we have the same letter representing 2 different things. So there's K for the springs, and there's K for the electric field constant. They're obviously not the same. And so be careful not to cancel out any K values. So what we'll do is we can just pick one of these and draw a free body diagram. Okay. Now they're going to double. The distance is going to double, right?
Double?
That 8 is going to turn into 16. That's what it says in the question. Okay. They're separated by 8, then there's charge. And plus they're not stretched at all right now. Okay.
They're stretched.
No, they're not stretched or compressed right now. In this picture at 8 centimeters, they're not stretched.
Oh, they're compressed?
And no, they're not compressed either. But what's going to happen is if you give them a charge, that's going to squeeze these springs, right?
Squeeze it, so the distance is going to get bigger.
So this distance is going to increase by 4 centimeters this way.
And 4 centimeters.
And 4 centimeters that way.
Okay.
Plus the original 8 makes a total of
16
centimeters. And so the trick here is realizing that your compression is 4 centimeters, right?
Oh, compression.
Okay? The compression in the spring will be 4. Some students will think it's 8 because like, oh, it doubled 8 to 16, so that's 8 centimeters. But that would be if all the distance was on one side only, but they each get 4 centimeters each way, right? So anyway, let's just pick this guy. We draw a little free body diagram. Actually, forget the force of gravity. We don't really need it. There's a normal force. So let's just look at, okay, well, I'll put it, whatever. I'll just put it. So there's gravity. There's a normal force. The electric force is pushing that guy away from, like, let's call this A and B. So sphere B is being pushed that way by sphere A, being repelled by it. And then there's a spring force pushing in the opposite direction. And the acceleration, whoops, is 0. So that's your free body diagram. Now we actually don't care about these 2 guys. They cancel out anyway, okay? And we don't need it to answer the question. But we do have this, that the force on the spring will equal the electric force, right? Okay.
Yeah.
And so I'm going to write
The formula for each.
Ks for spring constant K, okay, times X. Remember the force on the spring is Kx.
Is this squared? No, it's not squared.
No, it's not squared. That's
No.
the energy in the spring.
Yeah.
So this is a force problem, not an energy problem.
Yeah.
Okay, and that's equal to Ke. I'll put for K for electric fields, Q1, Q2 over R squared. Okay. Now the Q1 and Q2 are equal, and they tell you what it is in the question.
Oh, yeah.
2.5 times 10 to the negative 6.
So we know we don't know the constant for Fs. We know X.
Well, you know that Ke is 9 times 10 to the 9, because that's just a universal constant,
Yeah.
right?
And R is 4.
No, R would be 16 meters, like, or 0.16, because it's
You're
the
taking
it's
each
this
side,
number.
right, by itself.
No, but R is the distance between the two spheres. That's
Okay.
16. Okay. X is the compression of one of the springs. So X would be 4 centimeters. So 0.04 meters, like that. And so your only unknown is Ks, the spring constant. So you just solve that equation for Ks. And that's it. Right? Just don't cancel out these two Ks. Like, it's unfortunate circumstance where we have the same letter representing two different things. One of them is the like a universal constant, and the other one is for the spring. Okay. All right. Anything else?
So we're finding Ks, right?
Yes.
Interesting. So next question.
You know what? I should say to all of you that it's all in the details, right? So like the little details, like figuring out, for example, that the stretch or the compression in the spring would be 4 centimeters, right? Like this little guy in there would be 4 centimeters. Okay, and the distance between them, that distance is 16 centimeters. It's all the little details that throw people off. Okay, the basic question, just putting these two things equal to each other, is not that hard. Okay, it's just this formula here. It's not too hard, but it's just the little details, like working out these values here, makes these questions a bit tricky. Plus, it's a new kind of question.
Oh my god, my mom is calling.
You gotta go, Hala. That's your mom calling.
Hold on, just give me a second. I'll text her. She'll know.
Is it just me, or do family members, they don't text, they call?
Yeah.
That actually gets on my nerves.
Like, why?
I know. I tell my boys, like, just text me, stop calling. All right. So, what else?
Okay, so
There could be other questions from other people.
okay, they can ask.
I know. I think they're just waiting for you to ask, Hala. Like, it's
Maybe they're just waiting for me. Maybe we'll share questions. I don't know.
maybe no one else has any questions because they're so smart, right? Like
No, I bet if this came on the test, no, everybody will struggle.
Oh, wait, I have a question.
Yes.
Okay, remember when you were talking about in your other lesson, like that equilateral triangle, and you were saying like they need to give you a point for you to find like the total electric potential energy?
Yes.
Okay, so one of the questions in the textbook like didn't give a point, and they just said to calculate it was number 8 for 359.
Okay.
But they didn't give a point.
Okay. So on 359. Okay. So let's look at it. So it
It's
doesn't
8A.
matter the order. What page is it? 359.
Yeah.
Way ahead. 3. 349. 355. Okay, wait a second. Oh, here we go. Which one? The number 8?
Yeah, 8A. Because B gave a point,
Yes.
but I don't
Yeah, okay. Yeah, no, I'm glad you asked that question. It's good. So, okay, so look, I'll just copy this question. Okay, so then I'll come over here. And I'll just stick it here. Okay. All right, so here's the question. Okay, so it says, notice how it says energy, not voltage. Okay, so here's the deal with a question like that. What energy means is this formula here. Let's pretend there was only one charge that was being brought in. Like, so here, I'll call this A, B, and C. So let's say, forget B and C. Let's say you're just bringing A in, and what you're doing is you're in your room right now. There's you don't have any charged balloons in the room. Then someone brings one in, okay? So they brought it in from far away. It's already got charged, and that's balloon A, okay? So what you're doing in question A is you're using this formula, K, Q, A over R, okay?
Mhm.
Now, here's the deal though. When you bring the first one in, it's free. It doesn't cost any energy. There's no gain or loss in potential. And the reason why is because there's no other charges in the room. Okay, so the first one, like the first charge.
A, right?
Yes.
So
Actually,
then what's the kind of
I didn't do this right. QAQ here. Let me write the formula as I wrote it in the notes.
What's QP?
So I'm sorry, I wrote the voltage formula. I got to write the formula for energy. It's K Q1 Q2 over R. Okay. And it's kind of like the binding energy was with gravity. But the first charge is brought in for free. Okay. So like what you're doing is you're going to bring in 3 charges into your room and you're going to place them in a triangle like this. Maybe you're doing some kind of weird experiment, who knows, but you got 3 balloons and the first one gets brought in. It won't cost you anything. No gain or loss in potential because that first charge, and it really doesn't matter which one you pick. You could pick A, B, or C. You're going to bring it in. Okay. And forget that one. That one's brought in. You put it, let's say we put it right there. And that's it. No energy there. So if you just have one charge in the room, there's no potential, okay, energy. That's change in the system by bringing one balloon into the room. But when you bring the second one in, let's say now we go to B, when you bring that one in, that's going to take some work because A repels it, okay? So you're bringing it in from a great distance. So your first charge, your first amount of energy will be bringing in the second charge. And so you're going to go K, Q, A, Q, B over R. Now, R would be that distance there, the distance between A and B. That makes sense? So you would just plug in the numbers, whatever they tell you they are. Are they all the same charge? Oh, no, they're on the diagram. So it's 2 meters on the sides of the equilateral triangle. They're all 2 meters, right? So what you do is you're just going to go 9 times 10 to the 9 times, and never put the signs in, but I'll explain. Sometimes you do get a negative number. 4 times 10 to the negative 6.
How do you know the first charge is free? How do you know A is the first charge?
But you can, it doesn't matter which one you start with. You could bring in B first. Makes no difference. You'll see when I finish this that no matter what you start with, you always get the same numbers, okay, that you're working with. So watch. K, and the other one is, what is it, 2? So 2 times 10 to the negative 6. Okay, and then divided by 2. All right, I'm actually going to work out this number because just to show you how it works out. So 9 times 10 to the 9 times 4 exponent 6 negative times 2 exponent 6 negative equals that divided by 2. 0.036. So this is 0.036 joules. Okay. So you brought A in the room, 0. Okay. Now you brought B in, and that's going to take from bringing balloon B into the room. That's going to cost you. You're going to have to do some work because they repel. So the system will gain in potential as you're squeezing these balloons into the same room. And that's how much potential is gained, 0.036 joules. Okay, now you bring charge C into the room. Okay, and charge C, I think, is negative, right? Yeah, so C is negative. So when you bring a negative close to a positive, negatives and positives attract. So you're going to lose potential as they come in. Okay, so these are going to be losses when you bring the negative charge in because the other two are positive. Okay, if the other two were negative, then there would be gains when you bring them into the room. But because they attract, it's attracted to the other ones, it's going to be a loss. Okay, so what you do with charge C, okay, is you have to do the formula twice. You're going to see what the loss in potential is because of the interaction of these two balloons, and then the loss in potential because of the interaction of these two balloons. So for charge C, you're going to do it once for B here. So you're going to say, okay, the potential is going to be K Q1 Q2 over R. So you're going to go, and it's going to be a negative because it's a loss. So you have to put the negative sign in. So you go -9 times 10 to the 9 times, what are the charges? 4 and 2. So like we get exactly the same numbers, right? Between those two guys. So I already know here, let me erase this. I already know I'm going to get negative 0.036 joules. If you do that, if you just put, what you're doing is you're putting charges B and C into there, okay? And now when you do A and C, okay, again, it's a loss. And you're going to go negative K times QA times QC, if you like, over R. Okay, and this time it's 4 and 4, so we haven't done that calculation yet.
Is it the same numbers?
No, no, because one of them is, they're both 4 now instead of 4 and 2. So you're going to get double, you're going to get 0.072, right? You're going to get negative 0.072 joules. All right, so if you look at what we've done, we have 3 numbers here. 1, 2, and 3. Now ask yourself, if we started by bringing a different charge in first, let's say we brought C in first, would we still be doing these 3 calculations and getting these 3 numbers, right?
I don't know.
Well, you would, because look, when you bring A in, so let's say you started with C.
Why didn't we do one for A?
Okay, well, just let me answer this question first. Let's say you start with C, okay? Then when you bring C in, it's free. Now, when you bring A in, you're going to do this calculation between these two, right? Okay. And then when you bring B in, you're going to do this one and this one. So there are 3 combinations, right, of charges. There's A and C, there's C and B, and there's A and B. You always have to do all 3, right? But I like thinking of it the way I told you. So I like saying, all right, we'll start by bringing A, I put it on the table. I got it in there. That's 1 taken care of. It's no calculation. Then when I bring in B, I do this calculation. So this is between A and B, okay? That's the potential between A and B. Then I do B and C, okay? Then I do A and C. So no matter what I do, no matter which one I bring in first, you're always going to be doing these combinations, this combination, that combination, and this combination, right? And then what do you do with all these numbers?
Just leave them.
No, you total them.
Add them.
Yes. So you're going to get, these 2 cancel out. And so you're going to end up getting negative 0.072 joules. Okay, and that'll be your answer. And I guarantee, I'm pretty much 100% sure that the answer in the textbook is wrong on this.
They don't put answers for these type of questions on the textbook.
Yeah, they're in the back.
Oh, really?
Yeah. But this is the worst section of the textbook. We're doing it right. But like when we first got the textbook, I had to go back and read to make sure I was doing it right, because like I was getting wrong answers from the textbook. And if that happens 3 or 4 times, you're like, what am I doing? But yeah, they've since published, like, whoever did the answers the first time just didn't know what they were doing. But anyway, we have the original edition of the book, so it still has those errors in it. But we're doing it right. This is how you do it. Okay. So I don't know. That's how I like to think of it. If you want to think of it, you just have to do every combination of 2 charges. So you do A and B, A and B, A and C, and C and B. You just do each combination, just add them up to get the total. That's what you do. Okay. Now that's if it's energy. If it's voltage, they have to give you a point, right? So yeah, and that's what they do for this second question here. Is not the same question at all. Here they're asking for voltage, because the word potential without the word energy in the backward, sort of language of physics means voltage. Okay, so the word potential means voltage, unless it's followed by the word energy, which then it means energy. Okay, so yeah, I don't know if you want to see that one or not, but do you need to see the voltage one?
I think I'm good
Can we
for
do a
that one.
question? Yeah. Yeah.
So that one's okay, guys? Yes?
That's good.
Okay. I mean, if you're curious, here, let me erase some of these things here. Get to clean it up. Okay, if you're curious, they're asking. I would only do this question once just to save time. Okay, I wouldn't do it from all 3 sides; it's a waste of time. But they're asking you. Let's put a point here. We'll call it point X. Okay, they're saying what's the voltage right there. Okay, and what you would do is, again, A, B, and C, you would have to do the voltage from A would be K Q A over RA. And so this little distance here would be RA. Okay. And it would be a positive number because that's a positive charge. And this test charge you're putting here is positive too. So they repel. And so you get a gain in potential. Okay. And then VB.
But how do we know where do you put the test charge?
Because it says to put it at the middle of each side, right? So I'm going the side joining A and C. I'm just going to do it on one side. I'm not going to do all 3 sides. It's a waste. But there is a little trick here. You have to go KQB over RB like this, but this is RB. And so it's not 2 meters, right? So this would be 2 meters on this side, and that would be 30 degrees. Because you're so good at geometry, you know that in an isosceles triangle, that's 60 degrees, right, on each vertex.
You put the triangle on whichever side, right?
Yeah. So like what you're doing is you have to work out what RB is. Like here, RB would be like, this is 1 meter. Okay, like the RA is one meter, but RB would be like, if you like, the sine of 30 would equal 1 over, or sorry, the tan of 30, pardon me. Oh, no, it doesn't matter. Here, let's do sine. Sine of 30. No, that doesn't help us, does it? Cos of 30 would equal RB over 2. Okay, there's a little right angle triangle there. So it's like going to be like, 0.866 or something, or whatever meters. But yeah, so that's it. So like you have to work it out. And then once you work out your voltages, see like this one here, RC, that when you do VC, you have to put the negative sign in it, KQC.
Oh, because the negative.
Yeah, because it's a negative charge, it attracts our positive test charge, which means you get a loss in potential. Okay. And so this one is a loss. It's like the one time in this unit we're putting a negative sign in for, like, some students will make a mistake and put negative signs in for charge. My rule is never do that, because like you'll most often get the wrong answer. But for voltage it works, you know, but I just forget it. Just put, if it's a negative charge, put a negative sign in front of the formula. If it's positive, leave it positive for voltages. Okay. All right. So that's that question. Was there anything else?
I think I'm good. I don't know about the rest.
You're good?
Yeah.
Me too, I think. I hope.
Well, no.
Yeah, we'll go through the notes, and if there's any question, we'll just send it to you this time.
Okay. I think everyone else is very quiet.
Yeah, barely people in here.
Huh?
I said barely people in here in the
Well,
call.
there's 6 of you only.
Yeah.
Yeah, where's Claire?
Claire's not here. Let's see. The usual, like Charlize, Karen, they're not here either.
So, what do you think is gonna happen to our prom and grad?
Oh,
Oof, nothing. I don't know. I just got an email from or a text from Miss Mellenbrook saying that the talent show for tomorrow was postponed till June 11.
This is gonna be so
Bruh.
Yeah.
Bro, it's on a Zoom call. Why would it be postponed to
Wait,
another month from now?
they're still doing
probably
that?
because they're not
Yeah,
organized.
but they're doing it on Zoom.
That's crazy.
Yeah.
Yeah.
Who's participating?
No one.
They're like, I know Mr. Diab put a video together. I know like with his family that he's posting. So there's him. I'm sure Mr. L sings every week, like live online, right?
Really?
So, yeah,
Wait, what?
Wait, where?
on Facebook.
Oh,
Facebook is for senior citizens, right? So you guys are,
yeah.
but anyway, yeah, he does that. And so I'm sure he'll perform. So I'm sure Mr. like the usual suspects, like him and Mr. Chin or Mr. Photo, and those guys will put something together. It's a bit hard because you can't actually get together with people, but I'm sure they'll put in something. And I think some students were going to do things. I think.
Like who?
I don't know. Students with talent, not you guys, of course.
Oh, wow.
The talent show.
Oh, I have a question.
Yes.
So let's say I have let's say I wake up, obviously when you wake up, you didn't have breakfast or anything. You go work out.
Yeah,
Resume.
that's what I do.
Is it good? Because you don't have like any energy.
Apparently it is good.
It is.
And apparently, like, if you do, let's say you do cardio or you do like whatever, you're in
Not cardio, weights. Like
whatever you do. Apparently it's good to keep your body like, so if you're doing sort of the intermittent fasting where like everyone fasts overnight when they're sleeping. So like if you extended that time past your workout, so you don't eat right away, don't eat until it's like, say 16 hours have passed total between when you ate dinner and the next meal, the next morning, whatever.
yeah.
Then apparently it's really good. Like and I read that if you're doing weight training or if you're doing interval training, so I do that. Like I'll do
So before you have your meal, you
but
go.
you wait though. Like, so I wait. It depends. It depends on how hungry I am too. I'm not too strict about it, but apparently it's helpful. But I find if I do it, I'm not as strong, if that makes sense. Like if I work out right before dinner and I've already eaten that day, then I can do more. Like I can do more in my workout. I can lift more and have more energy. It makes sense, right? But apparently it's better for your body, conditioning wise, if you maybe are a little weaker because you haven't eaten for a while. then you do your workout, then you eat after that, right?
I have
Do
a
you think
question.
it's good? But let's say I don't have energy and I feel tired and I can't do much, but you know,
Well, you should take something. You could take something before your workout for that, like some energy, something, some carbs, but not a whole meal. Like just
but
something.
it's not gonna affect my muscles, like me getting weaker if I did this, right?
It does. Well, your workout won't be as strong. Like if you were playing a sport or something, this is not what you would do because you want to have, you want to be performing at your best.
But let's say you're eating right after your workout, like you're feeding your muscles right after your workout.
Yeah. So if your goal is to build muscle and lose fat, let's say, then this method is good. If your goal is to win a basketball game, then this method is not the method, right?
Mm-hmm.
If your goal is to gain muscle and lose fat, though, then this method works, even if your workouts aren't as strong as they normally are because you didn't eat as much, right? But that's the theory anyway.
Yeah.
But of course, don't starve yourself. Like intermittent fasting doesn't mean you don't eat, right? It just means you eat. You can eat for 8 hours a day. You can eat, right? Just don't eat outside those 8 hours. So let's say 9 to 5, you could eat. Just don't eat outside of that.
If I ate like dessert or something, is it okay?
If you ate what?
Dessert.
Dessert?
Yeah.
Well, sugar, really, people shouldn't eat sugar, but.
No, but like maybe my sugar through the whole day, like I eat, like let's say my lunch is good, like my lunch is.
Well, if you want carbs, don't eat sugar. Eat fruit and vegetables and stuff. Just don't eat anything like with sort of refined sugar in it because that's not really good for you. It's the only food that you can't eat really, that you shouldn't eat is sugar. But I mean, it's okay to treat yourself sometimes.
Like I treat myself once a day.
You're having a chocolate cake every day, that's probably not the best, right? Or a bowl of Fruit Loops or something.
Like maybe I have dessert once in a whole day. You know what I mean? Like not a really heavy dessert, maybe like a little bar of chocolate.
Well, what I do if I like dessert, like certain desserts I like, but I'll just have a small piece, So you could either have a lot of dessert once in a week, let's say, or have a little dessert more often, I like to think of it like that. But,
So, can your mark drop after midterm?
okay, so what I did for your marks that I submitted last week is I just looked at the mark you had before your midterm and the mark you have now. Whichever one was higher, I reported that.
Right, but for the finals, is it between
the same.
the mark you have at finals and mark you have midterms?
Yeah, so I explained, like the way I explain it is, okay, so let's say most of your marks went up in the pandemic. Okay, so for you guys, it was mostly good, the pandemic. There's only, I think, 1 or 2 maybe that I had to give them the midterm mark from before the March break. But like, let's say now we've reported your mark and let's say now it goes down. Okay, so let's say now you did really poorly or something and then your final mark is quite low. There's no final exam, right? So, but let's say your final mark is quite low or lower, then I would still give you the mark you had before the March break, right? So it's either you count everything after the March break if your mark goes up, or you don't count it at all. It's not like we only count some of it, or anything that can make your mark go up will count, but anything that makes your mark go down won't count. It doesn't work like that, right?
Okay. Also, how do we know we got wrong on our test?
On a test? Well, the thing is, okay, so when you submit your answers on a test, I have to mark them all individually because the computer, like unless you type in exactly what I typed in as the answer, the computer mark gives you a 0.
Oh, bless you.
That's COVID-19, whoever sneezed. Gotta isolate.
Ow.
Or if it's like, maybe it's allergies, eh? But anyway, so like, what was I saying? So like, yeah. So your marks. What am I trying to answer? I forget.
How do we know what we got wrong?
Oh, on the test. Yeah. So for me to send, there is a way I could send the test, like your test results, but then you're gonna ask me, like, let's say you got a mark of 38 out of 40 or something, and I send you the test back, and the test says 0. Okay, and then you're gonna be like, all right, so where did I lose those 2 marks? Because I marked the photo you sent in, and I assigned additional marks. The computer gave you a 0. And then you're going to be wondering, like, all right, so which ones did he assign additional marks for? And you're going to assume it's the one that you got the wrong answer for, right? But did I give you 3 marks for that? And then you got another one that was wrong, and I gave you 3 for that for a total of 2, like, so it's kind of complicated. Like, it's not simple because you're not going to
Well,
see
to see the multiple choice.
the multiple choice. Yes, that at least the computer does mark that correctly. So I could send that.
Yes,
But
please.
yeah, I could do that. I've been resisting doing it with my grade 9s because they're brutal. So there's only 12 of you. Like I get 100 like kind of ridiculous questions from them a day. Like, so if I were to send that to
It's not as annoying to you.
it's super annoying. I sent them this thing on doing significant digits, or whatever. And I sent them all the rules, all the directions. It's simple, right? It's easy. I just sent them 5 rules, whatever. And then I get 100 questions. And I just send them all an email. Read it, capital letters, read it. I have to do that all the time. So it's I'm really hoping, I know you guys you're graduating, you'll probably have online courses in university though.
What?
Yeah, I was talking to Rachel, and she was saying that like, I don't know for how long, but at least for now we're gonna have our courses online or something.
Yeah,
I wish it should be half the price.
Come September that you'll be doing just what you're doing right now.
Wait, are they still paying just as much for like university and stuff?
Oh yeah, I'm sure they're not going to charge you any less.
What?
They're not going to charge us any
They
less?
didn't charge you if you were going to go away and stay in residence. Of course, they're not going to charge you for that, right? That wouldn't be. But if they're going to charge you the same tuition.
No, it shouldn't be like that, because you studying online is completely different than going into university and actually being there in class.
Well, I agree, but I know
That's
they're
really
not going to discount it because they're going to be hurting for money too because of all this, right?
Like, basically, let's say the teacher is gonna come up and just make one-time video, whatever it is, and then let's say I didn't understand, and there's like hundreds of students other than me, and I'm here trying to teach myself. So literally, I paid, I don't know how much tuition is now.
A lot.
Yeah.
Yeah. No, you when you pay tuition, like my son is taking 2 summer courses, and it was a lot. It's like $1,000.
Yeah.
It's like $1,000 to sit here at home for an hour 3 times a week. Like, like when I see him sitting on the couch, like wasting his time, I'm like, this is not worth $1,000. Like,
yeah. Just for you to earn the credit, and let's say you earn it with a low mark because of the prof not being there to see you and see how you're interacting, and like there's marks for everything. It's not going to be fair to everyone.
No, it's true. But I mean, think about people who are going to go away to university. Like, what's the point? Like, there's really no point.
Universities are more expensive
Definitely,
than the other.
like I would say to everyone who is going to move away, don't move out, because you'll be probably 100%. Like if you were going to go to St. FX or something, 100% you'll be doing that course. Like in September.
Like some people are going to, I don't know, Queens, Miguel, whatever, these universities. And these universities are more expensive than, let's say, Ottawa U, Carleton.
Yeah.
So you're just paying their tuition for you to do exactly the same thing as anybody else is doing.
Yeah, just to take
And not
the online courses.
That's crazy.
Yeah. No, you know what? It's terrible. And I don't know, like school, I don't see how we're going to start. Like for me, I don't know how we're going to start school next semester.
Oh, in the US, there's some people that have started school apparently, but like only half of the people actually show up,
Well, in
or even
Quebec,
less.
in Quebec, high schools are not back at school. Only the elementary schools are.
Mm.
So I don't know who
It's
started.
worse. Which is worse?
Yeah. Well, elementary is because, like I said before, they had to get back to work, right? So, but like for high school, they were saying, oh, maybe we'll have them in shifts. Like we'll have half the kids come in the morning, half the kids come in the afternoon, and you only have 12 kids in your class, you know, whatever. And I'm like, you know, I cannot picture school like this.
Yeah, that'd be
Where the teachers are
The
wearing
teacher
masks.
has to be paid more. You know why? Because you're staying for 2 shifts.
Well, or they hire more people, but they won't do that, I don't think. You know, so it's going to be, you know, like I hope they get a vaccine soon because we got to get out of this situation. Like, it's a
Or
big,
just like let everything go back to normal and whoever dies, dies. And whoever.
Whoa, yo, chill.
Like, I'm serious. It's not going to end if this doesn't happen like that. Just
Well,
to make
This is
sure
really-
everybody gets it.
eventually, like some of these other viruses, like the H1N1 and stuff, eventually, like it does happen eventually.
Yeah.
But it's just going to take like we're trying to, the problem with this virus is they want to do that really slowly, right? So
Yeah,
let's say
they're really moving
you don't
slow.
care if everyone gets infected, you just don't want it to happen all at once. But if it happened over the course of 2 years, then fine, you know. But then 2 years is a long time to be like we're doing now, you know, like
Second year of university and I'm still on online. That's crazy.
yeah. And like I know that like I don't mind, like, you know, we're doing some online sometimes. I don't mind it. Like I don't mind this that much. I don't like it with the grade 9s though at all. But anyway, like some of it's manageable. But like I really don't like it for my own kids. Like my own kids is like terrible. Like I don't like it at all. Like a grade 8 kids, Nico gets nothing. It's basically no work. Like in a week, we'll do the work in 10 minutes. You know, like so it's this is not a way for an elementary for you to go through elementary. But at least the parents appreciate us more.
Parents appreciate us.
Oh yes, I've gotten like emails from parents saying, "I don't know how you do it." But it's not the same when you're at school though. School is easier, like it's when you're there.
100%.
Plus, like the kids, your own kids don't treat you like your parents. Like a teacher gets treated differently than a parent. You know? So, like, I find it really hard to teach my own boys anything. Mostly because they don't want me to be their teacher.
Yeah. My mom doesn't like it. My mom doesn't like it at all. She doesn't. She's like, where's the homework that you're doing? I'm like, I did it. She's like, I don't see you studying.
Yeah. I'm like that with those two.
Imagine for Arab parents not seeing their kids study.
Yeah.
Imagine for university being online too. She's gonna be like, you're not gonna get the education. Like, let me just send you back home. Because they don't care. They'll send you to university. They'll send you to university.
Yeah, no, it's true. Well, I mean, university are wasting a lot of money if you don't do it. So, anyway.
See, now you should take your nap because you're tired. Making
I
fun of
put it all down. I won't go to sleep.
You woke up what time?
I woke up at 7.
Oh, I sleep 2 hours before you wake up. Really.
Ooh. No, but
Like,
this is my time. This is my time to be tired. Like when kids come to me at school for extra help after school, I yawn and I'm tired all the time.
I know, we noticed that.
But in the morning, I'm a morning person. So in the morning, like if I get up in the morning at 7, like I am focused. Like I can work really well through anything in the morning. That's why in university, the exams in the morning, I was like all over it because I was really, my focus was great in the morning and afternoon, and I'm fighting fatigue. And I don't drink coffee or anything. So
Oh, I drink coffee crazy.
yeah, no, I don't know. I've never liked it. It's disgusting, right? For one thing.
The same. The thing is, I drink coffee, I still sleep.
Think about the first time you ever tried coffee, you probably spit it out. It was so gross. That's how it tastes to me.
No, it tasted bitter, really bitter. But
Yeah.
then after that, just you drink it like water.
Yeah, but like it takes getting used to it. Like I don't like those kind of things.
Oh.
But my wife's addicted, so if she doesn't have her coffee, watch out. She gets the headache and
I feel like Arabs, they love coffee.
yeah.
They,
Well, lots of people drink coffee. My mom drinks coffee. Like it's a common addiction people have.
oh, me, my mom, we're so addicted to coffee. Really.
If you have headaches when you don't drink it, that's addiction.
Yeah, actually. Like once I came to school and I forgot to have my morning coffee because I ran out of time, I was rushing and I was so angry the whole day. Like I was so mad the whole day.
Yeah, no, it's true. Like Dominique gets edgy and headache, and it's like, all right, let's get the coffee. But I get it for like I will drink. I don't drink any. All I drink is water. But if I'm driving, I don't, and I want to avoid fatigue for a long like road trip or something, then I'll drink like a Mountain Dew or something. And I never drink soft drinks, but like it has lots of caffeine. And the first time I did it, I was like, wow, like I'm awake.
Have you tried drinking Monster or these?
No.
These,
Like
like when I drink them, I'm awake for like another 3 days.
yeah, I feel like it's not healthy though. But
Yeah, sometimes you gotta do what you gotta do.
there's a student in Waterloo first year when I was in first year university that died pulling an all-nighter and drinking back then. Instead of it, power. What is it called?
Powerade?
No. What was the drink you just mentioned?
Red Bull Monster?
The Monster, yeah, or Red Bull, yeah, or whatever. There was one called Jolt. It was called Jolt.
Oh, its name. It's dangerous.
And it had lots of caffeine. And yeah, I guess the guy had an unknown heart condition and pulling an all-nighter right before an exam and had a heart attack and died.
See, it's universities that drive us crazy, really crazy.
I always went to bed though. I always got like 8 hours of sleep. It's like, whatever, I'm done studying. That's it.
No, like if me during high school, I'm pulling it all-nighter. Imagine me in university. I'm not going to sleep for the whole week until the weekend.
Yeah, but you see, when you're taking math and physics and stuff, they're not going to ask you a bunch of questions that you've seen already, they're going to ask you like to think outside the box. Like they're going to ask you ones where you have to be able to concentrate, so if you're fighting fatigue in the exam, it's not good for your concentration,
Yeah.
So I always I studied a certain amount and then that's it. Going to bed. But anyway.
Yeah.
All right. So what? We'll have a test. There's only
Wednesday.
6 of you here. It's only half of you, but
Let me see. Hold
Thursday.
Tomorrow, hala. That's
Thursday.
Yeah, chill, bruh.
Thursday. Not this Thursday. The next Thursday.
not next Thursday, genius. That's too long.
I mean, no. Okay, Friday. Friday sounds good.
Yeah, Friday. I like
Friday
that.
sounds good.
I'd say Tuesday. I'll say Tuesday next week.
Okay.
Oh, bet. Okay, say less.
That's
Okay,
like,
like Friday's a little too soon because what are we today? Are we Tuesday? Yeah. So like we have to finish the unit, then there's a practice test. So Friday's a little too soon.
Tuesday, Wednesday.
So like maybe we can do another, like if anyone has any questions on Monday, like and then but I'll post the rest of there's only 2 lessons left, or so.
Yeah.
There's actually a video online that I was going to get you guys to watch of an experiment, but whatever. Well, I'll explain it in the notes anyway. So we would have not done this. It's not an experiment we can do because the equipment is too complicated, but it's done in a university lab. So I usually just show the video and we look at it. So anyway, there's also like, I don't know what you think of this, but since there's no exam, I was going to not do the independent unit, but since there's no exam, maybe we'll do the independent unit then. Just do it together. It's on relativity, and it does come up in university, like it's not optional like unit really. I only make it independent because it's easy to do on your own, and we don't have time in class, like honestly we don't have time for that unit. So because we still have, what do we have left? We have this unit, then we have waves and light, and then quantum. Quantum is very short, it's only a week, but the waves and light takes a couple of weeks, and we're in the middle of May, right? So but there's no exam, so we'll go to June 20 or something, So it should give us time to do everything. But we might as well do the independent unit. It's a good unit, it's fun, it's interesting. But the next unit we'll do is waves and light.
anyways, we'll let you go.
Yep, sounds good.
Have a nice day.
Have a nice day.
I gotta get back to my talent show video,
Okay. Don't forget the Elsa costume and
Oh, you know what? I've already filmed that part.
really.
Yes. And like I did it at school. And some woman, I was on the roof of the school.
Oh, you were?
I was. And there was a young woman across the street who saw me, and she's like pointing. And I was like, I waved, And anyway, so I'm sure she didn't recognize who I was, but still I felt pretty stupid. There was a traffic police who also gave me like a weird look.
Yeah.
Because I was driving my car and I was like, oh, there has to be like somebody directing traffic. The stupid lights. But anyway, so yeah, I thought I was gonna have to upload that video like in 2 days. So I've been working on that. Like I was gonna work on that this afternoon, but now it's June 11th, so.
Oh, why? Like,
yeah, they changed it. Knowing your luck, like you guys, it probably won't happen at all, which I would, it's kind of funny.
oh, we're not lucky at all. We're not lucky. Like, we're just unfortunate kids. The new decade is not for us.
Yep, class of 2020.
Yeah, we made history. We really made history.
We did.
Yeah.
Like, we should be proud. We shouldn't be
officially the worst year ever to graduate, right?
Yeah. It was like when, it's history made.
Yeah.
I'm not disappointed because this wasn't ever done before. Like,
Oh no, I mean, who could have ever guessed? Who could have ever guessed this? This is just ridiculous. It's just, yeah.
I'm gonna tell my kids I didn't have proms. Can I go to your prom too?
Well, it's kind of weird. They say, it's like you're in the middle of a war, but it's not really that. I don't really feel like I'm in much danger sitting at home.
Yeah.
But it's sort of like a war on boredom. Like you just.
Yeah. Yeah.
Yeah.
Anyways, have a good day, sir. And thank you for today's lesson.
Oh, you're welcome.
Thank you, sir.
You're welcome. We'll talk soon.
Okay.
Okay.
Okay, bye.
Bye bye.
Bye.